All right, can you hear me? Sort of? All right, I'm hearing an echo, so I'm assuming that means you can hear me. Well, welcome. My name is Justin Lee, and I work for Red Hat. I don't know if you can see that in the back, necessarily. The screen is... Sorry, the screen is lower than I'm used to. So anyways, I'm going to talk today about Quarkus. How many of you have heard of Quarkus before? Okay, so if you were in Burr's talk yesterday, this is going to be very, very similar, which is sort of unfortunate, but maybe not necessarily. I'm a developer on the Quarkus team, so I'm working, for the moment, specifically on integration with the Amazon services. So how many of you were just in Arun's talk? Some of you? So when he was talking about the serverless application model, the SAM, I'm working on making Quarkus work in that sort of environment. It's not quite there yet, but it's very, very close. So that's what we're talking about today. So for those of you who don't know what Quarkus is, let's go through it. So it's a stack to write Java applications, which is not terribly unique. You know, there's 1,000 of those out and about. But we're choosing to focus on cloud-native microservices in serverless particular applications. So one of the things that makes Quarkus slightly unique amongst the field is it's very opinionated. How many of you write Java EE applications? Right? There's a lot of choices, and you have to like pick and choose, and what are we going to do, this and that. Quarkus tries to make a lot of those decisions for you to try to streamline those decisions. So what we're looking for, what we focus on as a team, is we want a cohesive platform optimized for developer joy. And developer joy is, I'm not a huge fan of the term, but here's kind of what it means basically. So we're based on standards. Anyone familiar with the microprofile specification? It's like a subset of the Java EE. If Java EE is this, and it feels like it, microprofile is this. So it gives you a very constrained micro platform to build on. So we are based loosely on microprofile, but we don't claim to be microprofile for various reasons. So based on standards, but not limited to it. We work on a unified configuration. If you've ever written an EE application, there's, you'll have your Hibernate configuration, you'll have maybe your JNDI, you'll have all these different configuration files kind of all over the place, which, if you're used to it, is, you don't feel the pain anymore. But certainly as a newcomer coming to a Java EE application and you're trying to write a new one, you have to figure out, like, where do I put this property? It can be confusing. So we unify the configuration into one file so that all you have to worry about is just one place, and that's where all your configuration lives. We also have a live reload mode, which is super handy, which we'll see in a second, which means that once you start up your application and you're developing it, you change your code, you change your Hibernate entity, and it all just works. By the time you switch back over to your browser and hit refresh, your application's done. And if you've ever worked in EE for long, if you're trying to restart your EE application, it can take 30 seconds sometimes to relaunch your application with an update. So we've tried to fix that. The big thing here is what we do is we streamline code for 80% of the common usages. So all the common patterns, all the common things that you want to do, we try to streamline that for you so that we take care of most of it for you so you don't have to worry about it. And then we try to be flexible for the other 20%. Because if you try to automate all the things, eventually you're going to do something in a way that works for the framework but doesn't work for you in your particular situation, right? So we try to get as much of it done for you as we can, but leave enough flexibility that if you need to do something on your own, we don't get in your way, right? And then we have also, which we'll see, we can actually generate a native image for you at the end of the day. So instead of deploying a giant JVM to EC2 or whatever, you can deploy a single binary like you would like with Go or whatever. You have a single binary, you deploy it, and it starts up very, very quickly. So our tagline is supersonic subatomic Java, which is kind of clever, I suppose. But what we like to focus on here, if you look at a traditional REST and JPA application, on a normal stack, can you all read this? It's all like dots for me up close, so hopefully it's readable from afar. It's a little small, perhaps. So this is a traditional cloud-native stack. So if it's like a Glassfish or WebLogic or JBoss application server, you're looking at 200 megabytes just to run your application, right? With Quarkus and OpenJDK, we're running at 130 megabytes. So it's what, 80 megabytes smaller already. And if you run it in our native mode, you can actually run the same application in 35 megabytes of memory. So we try to, the tagline is 100 times faster startup, 10% of the memory in native mode. So if you deploy like in serverless situations, this can be super, super helpful because suddenly the resources that you need to allocate and then more importantly pay for can be vastly smaller than you would in a traditional Java deployment. So, and another benefit is we unify the imperative and the reactive models. So often if you're looking at doing like a reactive REST interaction, you have separate APIs that you have to do, separate frameworks. And if you're in a more imperative kind of request response blocking sort of mode, that's a separate API as well. So what we've tried to do is we've unified that API, so whether you're doing like imperative blocking calls or reactive calls, it's all one stack, and you don't have to worry about switching back and forth between frameworks to get that done. So we try to bring in the best of breed frameworks and standards. So these are some of the things that we support already out of the box, because again, we're based on microprofile. And so if you use these applications, you're in luck, because as my colleague Emmanuel once said, you already have 5 years of experience with Quarkus. Because these are all technologies we've been using for a while. We just kind of bundle them and package them in a nice solution for you. So you're not required to learn necessarily new technologies in order to get up to speed on Quarkus, because it uses stuff. If you've ever used REST Easy, or everyone's used Hibernate, right? JPA should be familiar to most EE developers. It works out of the box. And we'll actually see a Hibernate example in a few minutes. So Quarkus is based on extensions. We have a core that does most of the magic for us. And we have a whole ecosystem of extensions. Now, we've developed a lot of these extensions, but we're also working on making it possible. It's possible today. The documentation is not great, which we know. But if you want to write your own extension to integrate some technology that we haven't done yet, then it's possible to write your own extension and get all the benefits of Quarkus, even though the library that you're using hasn't really been touched by us. So how it works is we do a bit of magic at build time. So like if you have a Hibernate application, the cost of starting a new application like that is at runtime, when it starts up, the system has to scan all your source code looking for all your entities, all your REST endpoints, things like that. So at build time, we track those when we compile, and we actually generate new classes so that we know what those things are at build time. And then when it comes time to start up at runtime, we just run those classes instead of your classes, which then delegate to your classes. And that saves us the cost of doing the runtime scanning and reflection at startup, and we can get very fast startup times even in JVM mode without it necessarily going to the native mode. So that's the magic of Quarkus, and this is where the extensions come in. There's a little bit of work sometimes on different applications, on different libraries, that Quarkus needs to be taught how to process some of that, and that's what the extensions do for us. This is especially important in native mode. It's a little bit less urgent in JVM mode, because you're still ultimately running a JVM, and if you have to fall back on traditional functionality in the JVM, it's fine, because it's just a JVM. So we'll see a full list of things in a bit. Now this is where we're going to do a demo, and this is where we'll spend most of our time. So we'll get to it. Are there any questions before I go on? It's all making sense. It's all very abstract, I'm sure. So if I can get my computer freezes up sometimes. What is going on? I meant to restart it. This is the conclusion we'll get to eventually if you want to read it now, I guess. What is going on? Well, it's completely unresponsive. All right. We will go. Oh, nope. We'll just reboot. I don't know what just happened there. So, anyways. I like the animation, by the way. It's really nice. There we go. I had to reboot, so that's why the video left. It's getting there. Aha. There we go. All right, we don't need that. All right, we were going to do a demo. We might do it with the Voxed animation on top of it the whole time, which would be pretty. Do you know why it's doing this on the screen? Pardon? Where's my picture? There we go. All right. Finally. Okay, so sorry about the interruption. I don't know what happened there. All right, so to begin with, what we're going to do, if everyone can read this. All right, is that big enough? Can everyone read that in the back? All right, let's try this again. So to start with, we have a Maven plugin to get you started. We also support Gradle. That's a work in progress. Everyone use Maven, I hope? Familiar with it? Perfect. So this is all on our website, but for now, this is the invocation to run the Maven plugin. And we run it, and it'll generate a project for us. And we have a basic project. So let's open it up in here. We have, haven't I already, all right, oh, maybe it'll do this for us. This might be a mistake. It's loading. I'm going to raise the font for you guys because otherwise it's unreadable. I'm going to make this bigger. Apply. And then the editor font. We're going to make this bigger as well. All right, is that readable in the back? Roughly? I feel like the sidebar might be too small. So let's make this 20. Okay, well, here's our basic demo app that Maven generated for us, and we have a basic, if we come in here, we have a basic resource. Right now, all it does is hello, right? So to get started inside all this, the quickest way to do it is we can come in and tell Maven to compile it, and then we're going to be in Quarkus dev mode. So compile is just the normal Maven compile, and we have an extension called Quarkus dev. And what it does is it'll launch your application and it'll watch your source tree for you. So if you make any changes, it knows to reload your application. And then if we were to load up our application, let's turn off the bookmarks. So this is the basic root page that you'll see when you load up the Quarkus application in the root. So this at least you know your application is up and running. But our endpoint is at hello. So we get the basic hello response, right? And if we wanted to change it, because the proper thing is to say hello world, we can just come back and hit reload, and it loads automatically for us. Now this gives us a very natural kind of turnaround time. Your normal development cycles all work within Quarkus, even though we're doing some special things down the line that are a little unusual for Java developers. So, but we don't want to do just a plain hello world. We want to do something a little bit more interesting. So what we're going to do is we're going to build the to-do app, but we're going to need a database. So I'm going to come back here, and I'm going to start Postgres off in a Docker container. I don't know if you can see those logs, but it's just Postgres starting up. So here we are over here in dev mode. Now what we want to do is we want to create our to-do entity. So what we're going to start off with doing is we're going to change our path to, we're going to change it to be at API instead of hello. And then we're going to, our endpoint, we want to produce JSON, but we also want to consume it. So we'll do that. And then I'm just going to, so we want to be able to list all of our to-dos. So instead of saying hello, we're going to have this. No, we don't want to do that. Now, so here we don't want that to do. I deleted that. There. I don't know what Sun's to-do is. So we have a new entity type called to-do that we want to work with, but we haven't defined it yet. So we can come in and we can create this class. We're going to put it in there. And then we're going to give it, a title. And just to save some time, because we had the reboot fiasco, we're just going to cut and paste here. So we're going to have some public fields. Now, all of us are Java developers, right? No one's like coming in from Python. Your first thing as a Java developer, you're like, all your fields are public. This is bad. We've been taught for 20 years, private fields, public getters and setters, which you can do. But we're going to be using a library later called Panache, which is an extension that we've written for Hibernate. It actually works better with public fields because the reflection, it removes some of the reflection stuff that we're doing later. And what will happen actually at compile time is we will do some bytecode magic to help encapsulate some of those fields for you. But you get better performance by leaving it like this, and then we kind of clean it up as part of the build process, which feels unnatural as a Java guy, I will admit, but this is the recommended. So we want it to be a Hibernate entity, so of course we give it the @entity annotation, and we want our title to be unique, so we will say, we want it to be not blank, because it's going to be our ID, and then we want it to be, unique because it's a column, it's the primary key. Now you notice we're getting a whole bunch of reds because we don't have Hibernate in there, right? So what we're going to do is we have an extension inside Quarkus that supports Hibernate, and we want a number of different extensions. So what we're going to do is we're going to come in here, and we are going to add some extensions. We also have another part of the plugin inside Maven, and I'll scroll this up so everyone can see it. Can everyone read that? I'm not sure how to make this part bigger necessarily without freaking everything else out. But we have a plugin called Add Extensions, and then we're just going to list the extensions that we're going to add. So in this case, we're going to add the Hibernate validator, and then we're going to add the JDBC PostgreSQL support so we can get the driver. We're going to add REST-easy JSON-B so we can get our JSON mapping. And then we're going to add the Hibernate support with Panache, which we'll see. Now, what's nice about this is if we come back to our POM file, we can see our dependencies, and Okay. So we don't have that much in there at the moment. We just have REST-easy support because that's what does all the HTTP stuff. And we have some testing bits. So we're going to add some extensions. It's going to run. And if the internet doesn't fail me. As you can see here, we can see the green check mark. We added the 4 extensions to our POM. And if we come back to our POM, you can see now the extensions showed up in our POM file. We will enable auto import, so the IDEA comes back to it. And if we come back to our IDE, or to our entity, as you can see now, it knows what these all are. So we can add our column, we can add the entity, and now no more red squiggles. So we update it live, and then we add the extensions. And the next step we're going to do is we are going to, so we have our name as ID. We're going to add a sort order. So we want to sort by the order column, but of course, order is a reserved word in SQL, right? So you can't use it, so we'll just rename it to ordering. And our next step. So if we come back to our resource, so now to-do is happy, but you see list all. It doesn't know what list all is, and it doesn't know what sort is. And that's because we're going to be relying on Panache. So what Panache is, it's a library that's built on top of Hibernate that tries to simplify some of your persistence stuff. It's designed to be kind of roughly in the direction of Active Record, if you're familiar with Active Record, but it's not exactly. So we're going to extend Panache entity. And now if we come back, you can see now list all, it knows what list all is. It still doesn't know what sort is, but sort is a type inside Panache, and we can just import it. And you can see here, we have the Panache.common sort. So, and we have 2 gets on this guy. So now our get all works just fine, and we've defined a list all. Oh yeah, I was going to show you the implementation, but I forgot. This actually gets injected at build time, so this is like the stub method that gets replaced as part of the build process. There's a fair bit of magic that goes on in the build. So if we come back, what we want to do, our old HTTP doesn't work, so we need actual functionality. Now, I'm not going to show this part because it's not terribly interesting, but there's a Node application that does like a to-do. All I did is, you can't see it because it's behind the podium. I just copied over a bunch of JSON and bits from an existing project because it's a whole lot of it and it's not terribly interesting. But, so we're going to use that, and if we come in here, we can see now we have all of our resources. So we have, here's our to-do HTML down here. This is all built on Node and Vue and everything, but if you know JavaScript, it might be interesting. Now what we want to do is we want to get rid of this index because we're going to co-opt that, so delete the index, and we're going to create a new resource here. And it's going to be called, I believe, index resource. What is the name of it? And we're going to cheat, and we're going to copy it over it as well. So what this is letting us do is when we get a request in on the root path, we're going to forward it onto our to-do HTML. Finish the imports. And this is just a redirect off a root to to-do. We could probably just do to-do as index HTML, but this is how this demo works. So we have that. Now if we come back to our root, we're going to probably get a nasty error. Right. So you get live errors in your browser, which is sort of nice. Rather than getting just inscrutable messages, you get some weird like 500 page or whatever in the browser. You can actually see your stack trace in it. Now, what the error you're seeing here is it doesn't know what these types are. The code that's running doesn't know what these Hibernate types are because we added them after we started it. So for the most part, you can reload your application, but if you change your dependencies, you have to come back in and you have to restart it, which is unfortunate, but there's some technical reasons around that. So we get another error, and that error says what? Right, there's no JDBC driver, so we have to configure it. So remember how I mentioned the unified configuration, where everything's all in one file? That looks like this. So we're going to come in, Brought my mouse out for a reason. So we're going to define it. Now, this is all in one file. Can everyone read the gray? It's unfortunate. So in here, we have everything configured in one file. So we have our Quarkus specific information. So we have data sources. We have our Hibernate config, and it's all in one file, so you don't have to bounce around between multiple configuration files, and you can see everything. So what we're doing is we're defining the URL for the JDBC driver. We have a username and password, and we're telling Hibernate at startup to drop the existing schema and recreate it, because when we're in development mode, that's what we want. We don't want the existing data. So now the big test is, will this work? And the answer is, oh, no, because it didn't start because of the error, right? So we'll come back in, we'll restart it. So, check the time. All right, we're doing all right. So now we have that. Reload. This did this to me last time too. Oh, because while I deleted it out of, what's that? Well, that's for another thing. What's actually happening here is I deleted the index.html out of the source directory, but it's still in the target directory. So inside target, I'm just going to do this. All right. Now, will that do it? There we go. So now we have our to-dos, right? Now you'll notice there's nothing here. It's not terribly useful. So we're going to add one more thing here. We're going to add, now how many of you know about import.sql for Hibernate? When you're doing development, you can actually have a file in your resources called import.sql, and Hibernate will load those at startup. So we can come in here, say new file, import.sql, not SQL, SML. SQL, we're going to add it. No data, yeah, we don't care about that. Change dialect to, fine, stop complaining. Well, whatever. So now we have actual resources in our database, right? And we can play with that. So we click, we're going to say we're done with all these. We're going to clear the completed, but nothing's happening, right? So we don't have these endpoints defined, which is fine. So we'll come back into our resource over here, and we're going to minimize these because we don't need them. So let's add an endpoint. The first thing we want to do is we want to do index resource, blah, 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 here. We want to update. So what this does, we're going to patch, it's transactional, return response, path param. So, okay, so to do an update in REST, we're going to use the patch method. We're going to take a path with an ID. We're going to update it. We have a path parameter. We're going to take in an ID element, right? So what's happening here is we're going to load our to-do by ID. So this is a Panache-generated function for us that gives us an automatic finder for our by ID. We're going to set it to completed, and then we're going to return. Now you'll notice at no point do I actually save the entity. Did anyone spot that? Like I changed it and I just returned it and I didn't save it, right? Because of the magic of Quarkus and Panache, that's actually handled for you. So you get automatic entity saves. And if we come back to our web app, we can reload, and now you can see all the items that were done, except for one of them. There we go. So we have one completed, and here we have all. So if we come back to all, we can update. There's still no clear completed, but we can do this. We can only see completed, we can see the active. So if we implement clear completed, it's going to look like this. So in this case, we're going to run a delete with a delete endpoint. Come on. Now, what didn't happen is we didn't get this delete completed for free because there's no way for Panache to know that, so we're going to implement delete completed. So we come into our to-do method. We're going to create delete completed. And then we are going to say it's a static one. So it's going to look like this. Let's create clear completed. All right. I'm trying to remember the syntax for this. So we're going to say to-do delete. So delete is a method that we do get from Panache, and so we're going to have a query. So we're going to look at completed. Remember, we have the field up here called completed, and then we're going to say true. So what this does is it lets us define a query with a single line that says, find me the completed with this value. In this case, it's true, and it's going to run the delete on them. So with Panache, you can define these queries like this in very simple terms. So you can write your business logic queries with as little code as possible. If you need a more complex query, you can write a more complex query, and that works. But Panache helps make the simple queries, simple to write. So if we come back in here, we reload our application, so we see all of them. Now we're going to complete one, because we've seen hibernate with Panache. We're going to clear completed, and now as you can see, they're actually deleting out of the database, right? And then we can view, there are no more completed because we've actually deleted them and not just marked them as deleted. And then, so our next steps, let's see what, so we're going to do create, because it doesn't do much good to have an update, to-do application without an update. So if we come back into to-do, we're going to create, let me do it at the top, because it keeps scrolling off the bottom for you guys in the back. So we're going to create an update, we're going to post it, and then we're going to create a to-do. Now you notice here, we're taking in an actual to-do class and not like a random collection of strings and names and stuff. So this is where the JSON-B binding comes in. If you've ever done any REST action with, say, like Jackson, what will happen is the JSON comes in as part of the request, and then the REST-easy JSON-B infrastructure will take that JSON and create a to-do instance for you so that your REST endpoint can just deal with your entity and not some arbitrary JSON document. So we get the to-do, and we're going to call persist on the to-do, which is another Panache-provided method, and then we're going to return an OK response with that. So we come back to our application, we reload. You can see all of our things are back because it reloaded the application and it reran the drop and create and import SQL. But now we can create a new to-do, and we can say, go forth and conquer, as we are wont to do. And now you can see we have it down here as well. And we can see all of our active. There are no there's the one completed, so we're going to clear it, and we're done. So briefly, this is what it looks like to work with a Quarkus application. It's a normal Java development cycle, right? Which is important because one of the big selling points, and I'm going to start it, but I'm going to kind of cheat. So once you're done with your development cycle, you've done all your normal kind of Java things, and you want to deploy it into, say, like a serverless situation like Arun was talking about this morning. One of the things that makes Quarkus so interesting is you can actually build a native image for it. So we're going to come in here and we're going to say, well, let me stop this other guy over here because it's going to maybe freak things out. So you can actually, you can run Maven package like you normally would. And then there's a profile that comes built into the POM. When you generate your POM file via Quarkus, there's a profile that's provided called native. And if you run it with that profile enabled, what will happen is you'll see your normal, it's running package. Oh, that test is going to fail because we didn't update the test. So let me do this. We'll skip the test for now because whatever. So you get your normal native, your normal Maven build, but then you'll see down here a whole bunch of stuff starts happening. So what's happening right now is that we're actually delegating to GraalVM, and we're generating a native image out of your application. So when it's done, and it may take, it takes some time, I'm not going to lie. It usually takes a few minutes to run. Let me increase this font. So, conferences, Quarkus. So I'm going to cheat. In the US, we have these cooking shows where they're like, here's how to make a turkey. and all this preparation, and you put the turkey in the oven, and the turkey takes like 4 hours to cook. But no one's going to sit and watch a TV show for 4 hours waiting for a turkey to finish. So they pull this trick where they put the turkey in one oven, and then they reach into another one and pull out a cooked turkey, right? So I'm going to do a similar move, and it just died for reasons. I built this earlier this morning. So this is the native version of the application that we just saw. And if we were to run it, please, demo gods, don't let me down. So we're going to run Vault 11. Oh, you're going to do it. Fine. All right. Last time I ran this demo, I sacrificed some hardware, and it worked. So, all right. I know the problem. Quarkus right now, for reasons of compatibility, needs Java 8 because GraalVM only supports Java 8. And I'm currently configured to run Java 11, which is not supported. So let me try that again. And maybe this time we'll get to watch the whole build work. Conferences, Quarkus. I don't think this is going to work, but I'll try it. Yeah, all right. Fine, we'll watch it build. All right. It usually takes, in this case, like 2 or 3 minutes, maybe just a minute, but it'll run. So the advantages of this is, like I said earlier, not only do you run in less memory, but actually the binary size is smaller than deploying a whole jar. So if you're deploying, what in the world is going on? Oh, it's still, oh, right. The bytecode was still Java 11, and I was trying to package it with the Java 8 JVM. But when you have a smaller footprint and you're deploying it, not only does it take less space in storage up on, say, like Amazon or whatever, but you're shipping smaller bytes over the wire, so you can do your updates much more quickly. And if you want to run in JVM mode, we build a jar file for you that you can actually just say java-jar and run your application as, it's not a fat jar, but it is an executable jar. And so you can run it that way as well. If we were to come in, Dropbox, Quarkus, demo, target. So if you come, this is the target directory of what we've just built. You'll see here there's this lib directory. And if you look inside the lib directory, what you'll notice is 1,000 different jar files. Now this is, if you've been doing Java for a long time, this should look familiar to you because Java applications tend to have a lot of dependencies. So we don't build a fat jar by default for a number of reasons. If you're working with Docker, has anyone worked with Docker? Okay, good. So you're familiar with Docker layers, right? So what a Docker layer lets you do is, as you change your application, if there are bits that are exactly the same, it'll just reuse those old layers and only update the new bits, right? So that means as you build subsequent versions of your container, it doesn't take so long because it doesn't have to start from scratch. So this is a lot more layer friendly because it'll have already built layers with these jars in it, and then it only has to build like a new layer with your application jar in it. So it makes your containers smaller and faster to build. If you wanted a fat jar, for example, if you are deploying up into Amazon now, Amazon requires a fat jar. So does everyone know what I mean by fat jar? It's an Uber jar. So basically, it's one jar that has not only your application code, but then all of these jars are stuffed inside, or all the jar's contents are stuffed inside your jar. So you have like one enormous fat jar that you can deploy. And some situations require that. And if you need that, there's an option in the Quarkus plugin called uberjar, and you just say uberjar and you pass it true, and then you won't get this, you'll just get like one enormous jar. So if you need it, it's there. As you can see, this guy is still running. It's been running, one step ran for 50,000 milliseconds, 56,000 milliseconds. It's churning. All right, and it's done. And it took 2 minutes and 31 seconds. And now, let's see if it's going to run or if the demo gods are cruel. It ran! Did you see that, how fast it started up? It started up in like milliseconds, which is crazy for a Java application. And then if you come over here, reload it, you can see we have our application that we just built, except this is all running in native image. There's no actual JVM involved. I was going to say, I'll prove it. But if you come in here and grep for Java, you'll see all of that. This is actually IDEA. So it doesn't look as impressive because like, what is all that? It's IntelliJ takes up a lot of screen real estate. So let's get rid of IDEA. There. So I'm grepping the only Java process running is the grep looking for Java. So there's no JVM running, but we're still running our application. So your Java REST application, native image, no JVM. So if you're deploying to Amazon, now suddenly this startup time, is in milliseconds. So has anyone worked with serverless? A handful of you. That initial request, when it first comes in, if it has to take time to start up a JVM, it can take 3, 4, 5, 10 seconds sometimes. And in a serverless environment, that is terrible, because you want serverless to be fast. But in a native mode, your initial request can come up in a matter of milliseconds, which is ideal for serverless situations. Okay, so there's a few. Oh, I don't have I was going to show you the slides. Instead, what I'm going to show you is, if you go to our website at quarkus.io, you can see the full list of extensions. You can see them all over here. There's just, I won't list all of them necessarily, but there's dozens of them that we directly have implemented, and while we're working hard to build out this list for the things that I won't say that they matter to us, the things that we think are more critical to our users, we've tried to build out extensions, and there are still some being built so that when you come to Quarkus, you have a working ecosystem of things to use. Infinispan, Hibernate, we have Camel support, we have JDBC support for all the major ones, so SQL Server, Postgres, MariaDB, MySQL, depending on what you're using, H2 for your in-memory tests. So we try to be as out-of-the-box capable as possible when you come to us. But we're adding things constantly. And because we like to be complete, there's also in our plugin, you can say list extensions, and then you get a whole list of extensions as well. So there's a bunch of them. You can see we have updated versions of different ones. So these are the ones that are installed. And if you want to add them, you can either just use the name there, or you can use the entire. It's called GAV, Group ID, Artifact ID version. So if you're familiar with Maven, it's what you're familiar with. Org.quarkus : blah blah blah. So you can either use the short name if you want. Or the longer name is probably better if it's a common name. So those are the extensions that we have already. More on the way. And then I couldn't find Keynote because my computer died. So let's try. I'm going to come back. I think I'm done with the slides, but I thought I would just check to be sure. All right, because we got to our demo. Now watch, it's going to freeze again. So. We're going to have some time for some questions. I forget what time this session ends. So what we're looking for is we're trying to provide a full stack. So everything that a Java developer is used to, because some of us have been doing Java for a long, long time, and there's certain things we've come to expect. So, our persistence, our transaction management, we want all those to be available to Quarkus developers, and we support it both in live reload mode and native executable. So all of your transaction management still works. All the reflection stuff that you're used to doing as a Java developer still works in native mode. There's a little bit of work you might have to do, but we support reflection as well. And what we're aiming for is just massive productivity wins as Java developers. So we have simplified configuration. We try to keep code as small as possible with a familiar developer test loop. And again, we're trying to make the 80% of what we do easy. So you just have to think about it, but still leave room for you to do whatever it is that you need to do without getting in your way. Yeah, we've already gone over that. So, yeah, so that's the end of the slides, and I'm happy to take some questions. And there was one other thing I wanted to come back and address if there weren't any questions immediately. Yes?
From what I've seen
Okay, so the microphone's a bit late, but the question is, and he's right. If you look at this demo, there's a whole lot of like class path scanning and reflection, and the question is like, how does Quarkus fix that? Because that's why Spring Boot doesn't work on Substrate VM, which I think the Spring team is fixing. But what happens is, I don't have the source code open. So as part of the build process, what actually happens is we will look at your source code and we'll see that entity, we'll see that REST endpoint, that GET, that POST, whatever. So what we actually do is at build time, we will generate a new class that tracks all that information. So we discover all those reflective points and we generate a class that tracks that so that when we actually run your application, we're not actually running your code. We run our code that we generate that then brings your code up internally. But then since we're taking that kind of scenic route into your code, we already know what those reflective endpoints are. So all of your like REST endpoints are already pre-configured in the compiled code, so that it already knows like what endpoints to respond to. So it doesn't have to scan for them because we made notes of it during the build time, and at runtime we can say, here's your list of endpoints. Does that make sense? Yeah. So that's why I say reflection works. There's a question in the back. That's why I say like reflection works in native mode. There's a little bit of work that you have to do. There's an annotation that Substrate VM. It's like register for reflection. It's basically just a note to Substrate saying, make a note of this guy because we're going to need it in reflection, and then Substrate VM does some magic to make that available. And so that's one of the advantages of Quarkus is for some of these common things like rest easy and hibernate, like we do that work for you. So you don't have to come in and say, oh, I need to register this, I need to configure. There's a JSON configuration file that Substrate VM uses for like reflective items. We generate that for you as part of your build. So we take a lot of that work on ourselves so that you don't have to, if that makes sense. In the back.
Yeah, it's probably a little bit impolite, but you should anticipate the comparison with Spring Boot because it's very similar. And wanted to ask, first of all, the configuration file, single configuration file, simplified configuration, it's all good. On the other hand, in deploying on different environment, I want to see different configurations files. Is there a way, is there a facility to provide alternative configurations at runtime?
Right, so the question is, are there alternative configurations at runtime? I don't know the exact answer to that necessarily. I know there's a lot of work going on with the configuration process. There are build time configuration items and runtime configuration items. So there is some facility so you can reconfigure, especially like your data source endpoints, because you can have like one image and then like deploy for multiple environments, whether it's like per customer environment. So
my local development environment may contain one database, my production environment may contain
right,
another.
exactly. So yeah, staging versus production, exactly. So there are facilities to override configuration items at runtime, at deploy time. I don't know the specifics of those, but I do know that they are there.
Okay, and the second question, all the extensions you support, they somehow are mapped on corresponding, let's say, Maven artifacts, for example. I didn't see that you specify a version. Can I specify somehow the alternative version in case I don't want to use this version of I don't know, of some component or some extension, but another one?
So the question is about specifying alternate versions. If you look at the POM file, what we do is, at the very top of it, we have this dependency management section, if you're familiar with how Maven works.
Yeah, absolutely.
So in dependency management, we have this BOM file, a bill of materials. It's a thing that Maven supports. So for simplicity, we provide a BOM for each version of Quarkus that says, if you're using this particular, for example here, we don't specify a version because it gets this version as defined in the BOM. If you want to override it, you just specify a version inside your tag here, and then it's fine.
My question was primarily about the step when you edit new extensions. You, like JDBC extension, REST Easy extension, or something like this. All these extensions should somehow be mapped on corresponding Maven components. And And how can I specify the version of Maven component which corresponds to the extension?
How can you specify your own company's extension? I'm hearing like part of it.
When you using Maven, you added a couple of extensions in order to get your code compiled.
Uh-huh.
And we saw that after that, your Maven, the corresponding components got added to the Maven pom.xml.
Mm.
Yeah, and what is the mapping between the extensions and components, Maven components?
What's the mapping between the extensions and your own components?
Extensions of your Quarkus extensions and Maven components.
You're free to use whatever you want inside your POM. So if you wanted to add your own custom library, you can add whatever you want on top of the Quarkus stuff. So you can, whatever library you're familiar with using, you can just add arbitrary stuff to it. Now, where that breaks down, so like if you run in JVM mode, it's literally just a JVM application. Use whatever dependency you want, whatever library, framework, it just works because it still runs in a JVM. Now, if you're going to run in native mode, it gets a little bit more dicey, or a little trickier, because there has to be sometimes a little bit of work done to make that functional in native mode. But if you're running in JVM mode, you can use whatever library you want because it's literally just running a JVM.
Yeah, understood. Okay, thanks.
Okay, I think we're officially done. I can see Margarita in the back. She's ready to take the stage. I'm happy to answer whatever questions you have. Come up after, find me in the hallway, whatever, and I'm happy to talk to you. So I hope this was helpful. Apologies for the reboot in the middle of it. I don't know what happened, but thank you for coming.